Welcome to the fifth example in chapter 3. The question reads, the shear stress strain diagram for a steel alloy is shown in the figure below. If a bolt having a diameter of 20 millimeters is made of this material and used in single and double lap joints shown below, determine the modulus of elasticity E and the force P required to cause the material to yield. Take Poisson's ratio to be 0.3. Okay, so in terms of givens, we can start off with the fact that our diameter of this bolt that's in question is 20 millimeters. So we can say diameter is equal to 20 millimeters. We're given Poisson's ratio, and we can write that down as equal to 0.3. And we're actually going to write down, we know that Poisson's ratio is equal to, it basically compares the lateral strain to the longitudinal strain. But there's also another formula that we can use because eventually it does want us to find the modulus of elasticity. So another formula that is useful is that the shear modulus is equal to the modulus of elasticity divided by 2 times 1 plus Poisson's ratio, right? So we're going to use this lovely guy to find elastic modulus very soon. And we can find shear modulus as well, because I know that the shear modulus is just the yield shear stress over the yield shear strain, right? And I have the stress strain diagram right here. And in this case, it is simply 420 megapascals divided by 0.00545 radians, right? When it stops becoming linear is where the yield point is in this case for this shear stress strain diagram. So from this, I can say shear modulus is equal to 420 megapascals divided by 0.00545 radians. And this ends up being 77.06 gigapascals. And we'll convert to megapascals a bit later. And I think that's all for givens. Yeah, basically we can move on to unknowns. And for unknowns, we want to find two simple things. We want to find, for each case, we want to find the force P for the single lap joint and the double lap joint. We want to find the magnitude of this force P based off these constraints. And we also want to find the shear modulus. So we will do that. Or we want to find the modulus of elasticity, my bad. So we want to find the modulus of elasticity, and we want to find P for two cases, for single lap joint and double lap joint. But I think it's much easier to first find the modulus of elasticity because it's simply this formula. We have everything. It's just plug and chug. So we'll write that down. So find Young's modulus. Right. We start off with our formula. We can start from the general one. The modulus of rigidity is equal to Young's modulus over 2 times 1 plus Poisson's ratio. We simply isolate for Young's modulus, and we're going to end up getting that 2 times the shear modulus, or the modulus of rigidity, or whatever you want to call it, multiplied by 1 plus Poisson's ratio will give you the elastic modulus. Plug in the numbers. 2 times 77.06 times 10 to the 3 megapascals. Or actually, let's keep in gigapascals. You're going to end up getting a Young's modulus of 200.356 gigapascals as your answer to this first part of the question. Okay, next, we want to find the yielding force, right? The yielding force P, basically this force P. And if we draw case 1, and we'll call this the single joint, right? So for find yielding force. And if we draw case 1, we'll start with case 1. if we draw just this case 1 and we draw just one of the joints, we'll just draw this one, we will see that what forces act on this joint, basically. Well, we have, since it's a single lap joint, we have one force P, and what's the force that's opposing this motion? Well, we have one shear force, right? If we're looking at this bottom portion right here, we have one shear force. If this is P, we have one shear force in this direction. One shear force like that, and we call it V, right? So if we do a simple force summation in the x direction, we say this is positive, we're going to see that V is equal to P, and then we can simply find our force, right? Because we know that, and how are we going to do this? We know that shear stress is equal to my shearing force divided by my area, right? Okay, I want to find P. Well, I know that P can also, I can replace P with V, right? A shearing force, okay? So therefore, I can plug it into this formula, and I can isolate for V. And do I have shear stress? Well, yeah, I'm basically looking for the yielding stress, right? The yielding shear stress. And I have that, it's 420 megapascals. Do I have the area? Yes, I do. I can find it with the diameter, right? And that is what we're going to do. So we expand this out. The shear stress, or the yielding shear stress, multiplied by the area, pi over 4, times the diameter squared. Where you're going to end up getting the shear force to be, for this first case, 420 megapascals multiplied by pi over 4 multiplied by the diameter squared. You're going to end up getting that the shear force for the single lap joint has to be 131. I'm going to convert to kilonewtons, 0.9 kilonewtons. And this is, as we know, V is equal to P, right? Okay, perfect. We can look at case 2 now. And case 2 is a bit different, right? Because now we have a double lap joint. Oh, what the heck happened here? How lovely. Resize. Case 2 is a bit different because now we have a double lap joint, right? So we can write case 2. And in this scenario, we still have our force P, right? And these are the forces. I may draw it like this, but in reality, I'm looking at this bolt, right? I'm looking at what's happening at this cross section. I have, again, this force P, and then I have a shearing force in this case. But how about over here, when I look at this joint right here? I have my force P, but I also have not one, but now I have two shearing forces, right? Acting on my bolt at this section right here. So instead of one up here, one shearing force, I'm going to add two. One on this side and one on this side. So I'm going to write P. I have one shearing force like this and one shearing force like this. If I do the summation, forces in the x direction, set it equal to 0, I'm going to end up getting that P is equal to V plus V, right? And therefore, V is equal to P over 2, right? So in this case, I'm going to do exactly what I did before, but instead of plugging, just saying, okay, V is equal to P, I'm going to have to say that my V is equal to P over 2, right? Because I'm having two shear forces, right? So we can plug that in. Or you could also plug in 2V and then come back to this equation and sub in, basically divide your answer, but we did it this way, so hopefully it's just rearranging the formulas. your shear stress, right? So 420 megapascals, pi over 4, multiplied by your area or your diameter. Once you do this calculation, you're going to end up getting that your force needed for, or your yielding force needed for this double lap joint is a value of 263.9 kilonewtons, and these two guys are your answers to the second part of the question where you're finding the yield force, and this is your answer to finding the elastic modulus.